But first up, we've got Emily Freeman. Emily is head of community at Amazon, previously at Microsoft, has written 2 best-selling books. Anyone who knows Emily has been just admiring the work that she's been doing for many years. She's not only great at what she does, she's just a delightful human being. She's going to be talking about AI and developers and open source, so give her a huge round of applause.
Thank you so much. Good morning. Through heavy rain and thick smoke from artillery fire, Austro-Hungarian captain Maximilian Sternek found his way through a gap in the Italian battle line. While the Italians waited for signals from their vice admiral, the Austrians already had their orders: ram any boat painted gray. Sternek commanded the Ferdinand Max, the lead ship of the broadside ironclads, built for the Austro-Hungarian Navy in the 1860s and sheathed in 5-inch thick iron armor. A few hundred feet before his target, the armor-plated frigate, the Re d'Italia, Captain Sternek ordered the engines of the Ferdinand Max to be shut off, relying on momentum alone to carry the ship at over 11 knots. Recognizing the threat, the Re d'Italia attempted to reverse engines and elude the Ferdinand Max, but was unable to complete the maneuver before being struck on the port side. The iron ram of the Ferdinand Max punched through armor and heavy timbers in the Italian ship into the engine room, creating an 18-foot wide hole partially below the waterline. The ship sunk within minutes. The Battle of Lissa was the first major battle between ironclads, ships protected in iron armor plates designed to deflect explosive shells. These ships were constructed for simply 30 years between 1859 and the early 1890s and represent a small but pivotal moment in advancements of naval technology. For the 2 centuries prior, navies had primarily relied on ships of the line, warships designed for volley fire via cannon along their broadsides. Initially, these 3-masted vessels relied only on wind for propulsion, but began adopting steam power in the 1840s. These ships were big, fast, and heavily armed. The most common ship of the line, the 74, had 2 decks mounted with 74 smooth-bore cannon, but the largest first-rate ships had up to 4 decks and 120 mounted guns. But it was the advent of rifled cannon, which allowed greater accuracy and velocity, as well as exploding shells, that brought these powerhouses of the sea to their knees. The unarmored wooden hulls simply couldn't endure incendiary assaults, and it was that catalyst that brought about the ironclads. In addition to being skinned in iron, these ships were propelled exclusively by steam and armed with guns capable of lobbing explosive shells. Ironclads were extremely resilient to enemy fire. But for all of its advantages, ironclads had a few serious drawbacks. I don't know if you've noticed, but iron rusts. And it turns out, when you submerge wrought iron in seawater, it actually accelerates this process. Iron also becomes brittle in cold weather. And by brittle and cold, I mean below 68 degrees Fahrenheit. This means that the iron could actually splinter into shrapnel during a bombardment. Because of this, most ironclads continued to be built with 14-inch wooden hulls that would then prevent the shrapnel from harming the crew. But it was steel that ended the short age of the ironclad. Unlike iron, a natural element that can be extracted from ore, steel is an alloy made of iron, carbon, and often other elements that adjust for the hardness and strength of that steel. Despite the accidental invention of steel in the 13th century BCE, where we now call Turkey, steel remained relatively brittle and extremely expensive in the 19th century, especially at scale. Efficiency wins due to the Bessemer process in the 1850s and the Siemens-Martin open hearth process in the 1860s made steel widely available at an affordable cost. In 1906, the British Royal Navy launched the HMS Dreadnought, meaning fear nothing. The Dreadnought was 527 feet long and displaced 18,000 tons, making it the largest battleship ever built. And the Dreadnought was made entirely of steel. As I said, I'm Emily Freeman. I currently run community engagement at AWS, and I'm the author of 2 books. This shift in naval power was significant. The Dreadnought was armed with 5 turret guns and could hurl 850-pound explosive shells 14 miles, as compared to the ships of the line that could fire 10-pound solid shot a few hundred yards. The Dreadnought could not have evolved directly from the ships of the line. There had to be this transitional moment where extreme advancements in technology that set the stage for that next phase of evolution to come to fruition. There's a concept in evolutionary theory called transitional forms. And these are the fossils that we've discovered that represent the transition from one form of a species to another. For example, the Tiktaalik lived around 375 million years ago and is representative of the transition between non-tripod vertebrates, simply put, bony fish, and early tetrapods, 4-legged land animals. The Tiktaalik had wrist bones and the start of finger bones. It had ribs and a mobile neck, but it also had gills and scales and fins. It was the middle point between fish and, well, us. The ironclad was the transitional form between ships of the line and the steel battleships like the Dreadnought. And we are in the ironclad era of AI. Artificial intelligence is not new. In one of my favorite examples of life imitating art, it was science fiction writers in the early 20th century that cemented robots into our collective consciousness. The thresholds of sentience, emotion, and what determines life has fascinated humans for decades. Alan Turing, the British mathematician and computer scientist who implemented the concept of an algorithm with the Turing machine, could be called the grandfather or the father of artificial intelligence. Turing opened his 1950 paper, Computing Machinery and Intelligence, with the question, can machines think? Turing was unable to finish his work due to a life unfairly cut short and the limitations of computers at the time. While early generations of computers could execute commands, they had no memory capacity to store algorithms. They were also excessively expensive to rent, leaving only large corporations and universities able to contribute to the industry. Over the next 20 years, thanks to investments like the organizations like the Defense Advanced Research Projects Agency or DARPA, compute power increased, memory capacity expanded, and more people could access this technology. In 1970, Marvin Minsky made the bold claim that in 3 to 8 years, we would have a machine with the general intelligence of the average human being. A little off. Executing on this vision was delayed by the physical limitations of computers at the time. We simply did not have the computational power or processing speed. Now we do. And through all the excitement, we find ourselves unsure what the future holds. As technologists, we have long disrupted other industries, but now we find ourselves being the ones disrupted by machines, of all things. It's no secret that AI is turning the everyday work of developers upside down, and it's left many of us wondering what's next. Will the algorithms we wrote and trained replace us? Massive change is coming, and it's rapidly approaching. Just as steel became cheap enough to use for building ships, it is only in the last few years that compute has become cheap enough to make the dreams of the last 80 years a reality. We are in a time period of intense experimentation and uncertainty, and we are being bombarded by bold claims and intense warnings. Navigating the next 5 years in AI is going to be a wild ride, but if you can maneuver through the chaos, there are opportunities for all of us. We've been moving ourselves up the stack since the advent of computers. We solved hardware problems with firmware. We built kernels to manage a computer's resources. We developed high-level languages because writing assembly is annoying. What is a generative adversarial network, a GAN, or a large language model, LLM, if not the next phase of that abstraction path, where we no longer have to learn computer languages, but instead can utilize our natural spoken language to communicate what we want? We are not being replaced by generative AI, but our work and our value is changing. We benefit greatly from GenAI as it improves our productivity. It's no secret that code sidekicks like Amazon Code Whisperer remove the toil or undifferentiated heavy lifting of our everyday development work. We're entering a world where none of us have to write a form or a simple CRUD service from scratch ever again. And I don't know about you, I'm thrilled about that. These problems are already solved. We know how to do this, and the room for improvement in those areas is negligible. Continuing to have us repeat this process of writing code over and over and over isn't doing anyone any good. Now you can simply comment with what you want to do in natural language, and your tools like Code Whisperer or your preferred tool will deliver you with the best possible solution in code. The more specific you can be with your request, of course, the better the code will be. Instead of thinking like a machine and spending time translating your thoughts into code that will eventually compile, Code Whisperer auto-generates code based on your intent and matches your personal preferences and style. For me, responsible AI is an important part of the tools and the reference that Code Whisperer is one of my favorite features. If the code recommendation is similar to a piece of code in the training data, Code Whisperer delivers a reference to that code and includes the open source license the original author utilized. These references are important because we have to have a hard conversation around ownership. We share information, and these models are trained on existing data. And when it comes to that information, what is yours? What is mine? What is ours? No one is going to save us. We are it. We are the decision makers. We represent some of the best technical minds in the world, and we understand the technology, and even we are overwhelmed. How do you think the rest of the world feels? If anyone's simply reading headlines, AI feels like a tsunami bearing down on us, threatening us. We have a responsibility to ourselves, our communities, and our world to push for the responsible use of data by creating standards and guardrails. Still, for all the risks, GenAI is doing a magnificent job of redefining the role of a developer. When it comes to tech, we have a culture that takes pride in being able to do the hard things rather than make the hard things easier. Many of us are guilty of aligning our self-worth with being able to do the hard things. And I want to be clear, I'm not exempt from this. Being technical is powerful, and we have been able to leverage that power to improve our collective compensation and to also improve our working environments. That is not wrong, but we can maintain that power while inviting others to the table. This is not a zero-sum game, and AI is not a direct threat to your job, at least not right now. First of all, AI can't plug itself in, okay? That's our real advantage. And anyone who's ever worked in infrastructure will tell you that the internet is held together by fraying duct tape. Skynet is a ways off. Still, maybe we will get to the point when our current jobs are done completely by machines. That's possible, eventually, but we are nowhere near close to that moment. As it stands, AI is an evolution of our skill set. It is an abstraction of the fundamentally difficult things and an invitation that anyone can become a developer, no matter their background. As we evolve our skill set collectively, let's not miss the opportunity to grow our communities and redefine what it means to be a developer. I know many of us have an allergic reaction to these terms, but low-code and no-code tools that allow anyone to build custom applications and solutions without writing a single line of code is a catalyst toward expanding our influence and enabling others to enjoy the power of code without climbing over the sometimes overwhelming barriers to entry. We're going to be doing a lot more reading than writing over the next phase of our careers. Whereas the bulk of our work used to be writing code from scratch, as we move into an era of generative AI, I expect the bulk of our work to be shifted to reviewing generated code. This means an emphasis on being able to read code, understand architecture, and think through large-scale systemic consequences. That will be the true value of our work. That said, don't ever over-index on prompt engineering. I've heard a lot of talk about how prompt engineering is the next big title or role in tech. I don't think it is. I think this is a temporary moment, and it's a skill that we should all explore and learn, but my expectation is that as AI improves, honing perfect prompts will become less and less important. This is a chapter in a much larger story. GenAI is inefficient, and that's generous phrasing. Burning resources at the rate we currently are is simply not sustainable. We've proved the model, pun intended, but efficiencies are absolutely required to apply GenAI to other areas and industries in a cost-efficient and safe way. Right now, the applications are novel but low risk. Generating text and photos and code is fun and interesting and useful. But as we move toward implementing GenAI solutions in industries like medicine, commercial farming, defense, the bandwidth for failure becomes more and more narrow. Not to mention that any GenAI solution will need to be cheaper than the current, often manual and human-driven approach. Supervised learning, what is essentially taking a large-scale set of labeled data and training a model on it, is still currently the most impactful application of AI. And I suspect that as this technology evolves, we will see more specialized GenAI models developed that then are optimized for specific use cases and result in more accurate, cost-effective outcomes. We are in the ironclad era of AI, where technology has drastically changed, and we are experimenting with new possibilities. We are not at the end of the road. We are not the victims of our own invention. We are at the beginning of a very long, exciting journey. And we have the opportunity to wield both the power and the responsibility to determine what comes next. Thank you.